Hey folks, welcome to Breakneck, the podcast. I'm Ian Sweeney and I'm joined by my buddy Matt Pashensky. I am a mechanical engineer by trade and a product guy. And Matt, you are a physicist by trade, right?
Yes, I actually have
Okay,
relevant physics stuff happen this week, so that'll
okay,
come in handy. Every
all
two
right,
or three months, you get a
okay.
good physics is useful.
So Matt and I are also founders of businesses, and we're kind of living and breathing this question that many of us are confronted by, which is we've got AI. What the heck does that mean for my world, for my business, for the things we do? And so we've been having these fantastic conversations, learning off each other. And so Breakneck is really all about sharing that with you. So with that said, we'll launch straight into it. Matt, I have a question for you. AI is changing the world, the way we consume and we build products. We have old school SaaS. There's a bunch of changes to that world coming in terms of the ecosystem. You've had some interesting experience, I think, in the last week or so that's been thought provoking for you.
Yeah. No, I was just checking out the 2024 annual report for Atlassian. There's, I check these things out every once in a while, and I was wondering how much they spent on that company. What do they spend it on, right? And Atlassian made about $4 billion last year. Their revenue is growing just steady as could be. They're about a $70 billion market cap, something in that range. So very successful company. And I was just looking at how they actually spend that money, um, and it got me thinking. It's like, what's going to happen to companies like Jira or HubSpot or Salesforce? And between this report and talking with some insiders at Atlassian, for instance, they're going very heavily on an AI driven world. And what that's done is it's the groups of people inside Atlassian who are responsible for building like these really structured kind of, I call them like Web 2.0. It's like an
Hmm.
interface. You log into a website, you modify some data, you read some data. It's user generated, but you can also read and write. And it's a very structured way of a group of people all accessing reading and writing on a central data store. And but it's basically mediated by this UI. And then what it looks like when I read and I hear these stories about inside Atlassian, or I start to look forward at what's going on at Salesforce or HubSpot or those kinds of tools, which are kind of like my quintessential successful Web 2.0 style enterprise applications. Um, Everybody's starting to say, oh, well, all of this data is going to be available in a very unstructured way, which, and the big point I have is like, how do you defend a tool like a Jira or a HubSpot? I'm not saying they aren't going to do it. I'm saying how they go to do it? If that interface that kind of defined everyone's understanding of what Salesforce is. Salesforce is your opportunity pages, in my mind. Everybody logs in, they have many other lines of business and they make money in many different ways, but they are defined in the same as Google. You log into one page, you see it, it's that opportunity page. Google, it's a search page. Jira, it's your Kanban board or whatever you're logging into. And I think my big point is with AI, you could just talk to the computer. You don't need to go through this artifice of entering fields in your Salesforce opportunity, which no one does, by the way. It's like constantly heads of sales are like,
Yep.
no, they haven't updated their data. So it didn't really work that well, but it was the best we had. And now people can just chat with an AI. How does Salesforce work in that world? And they talk about agent force and stuff like that. I don't really know. I've watched the presentations. I don't exactly know what that
Yeah.
means. But
I
how do
think
you
it's
do a business like Salesforce when people can just talk and it's just
yeah.
unstructured? It doesn't need to be this opportunity format.
Yeah, it's very top of mind for me because the examples you picked are sort of sales sort of focus, right? Salesforce, I think you mentioned HubSpot as well. Well, Atlassian as well. So they tend to be siloed by function,
Hmm.
right? And they're really just a database structured sort of format, we've taught users over the years to be able to understand. Oh yeah, I see. Right, the title goes up here, and we do this and we do that, and it's all always a pain in the ass. And you have the same problem with HubSpot and Salesforce that you have in Jira. Like, oh, did you update your ticket in Jira? I'm not doing it on that. So we have all of that. The promise of AI is you don't have this laborsome UI user interface that you just sit there, right? You now can interrogate these different things. And so when I go to Agentforce, this promise of Salesforce generating all these agents, I think it's a fundamental issue there, which is I don't want to have to think of the world in functional silos. I want to be able to answer a question, not have to think, oh, the data's in HubSpot or it's in Atlassian or it's in whatever. And so we now have, and the other challenge these businesses have is they've all been API-ified over the last 10 years. So the data can now move freely out of Salesforce into something over here or into my new AI agent, which is really the glue that sits in between all of these things. So the way I think about it is as a user, it's great. The best UIs are the best one is probably audio, speech, right? Verbal. That's how most of us do our interaction. So I can get that type of interface to all of my data now. The APIs are there. I don't know what it means for the Salesforces of the world and all the other guys who essentially laid out the red carpet unknowingly and unwittingly for this type of a scenario where somebody can come in and create a sort of unifying AI that answers all the questions that Matt wants to answer.
Yeah, this is not one where I have answers. I don't know what's going to happen next, but I do know that like out of that 4 billion of revenue, sales Atlassian lost about $130 million last year, so it's not profitable.
Mm-hmm.
And they spent $2.5 billion on R&D or something like that. Don't quote me. Like, this is not investment advice, but like this is 2 billion, roughly more than half on R&D. And I don't know if you've ever used Atlassian Suite. There's not a lot of innovation over the last 30
Yeah.
years. It's a lot of money going into either they're doing something very big, but it's going to really disrupt their model because they sell seats, and those seats are interfaces with a set of UI elements is the basic sales block of all these companies. And Salesforce, $250, $300 a month for a salesperson to have a seat. What does that mean when it's just agents going back and forth? And I brought up HubSpot as well. I'm a HubSpot user, and I like it. And what it's doing is it has all of these little hooks. And so, for instance, every email that I write connects back into HubSpot, and then they're building this data store. And imagining that's exactly where all these companies are going to go. They're going to try to actually use this basis they have, because it's going to take a while for people to move off of all of these reporting systems and workflows, to be the ones who suck up all that verbal data, all that meeting transcript data faster than anyone else and be the last one standing. So anyway, that was my my observation this week.
Yeah, I think the other interesting thing for me about both of those examples, both in the sales world and in the software development world, both of those companies are in a spot that there's a bunch of AI investment and innovation happening. Right? So if you take Atlassian, they really think of a product development life cycle. They're really sort of, for the most part, at the back end of that. They're enabling developers and product managers to an extent. That's where all the money is going in terms of, how do we get that accelerate that portion of the life cycle of delivering a product, which is tough. There's a lot of competition for them.
Yeah,
So
but they're spending like they're still competing. I mean, they're not returning cash to shareholders, so
yeah.
a lot of investors like that. One last thing, and this is more of a question for you on the same topic. How do you like? I think this could be like the AOL to the open internet moment, where AOL was like this walled garden. And they always, the old state frame was everything is either bundling or unbundling. I think was Barksdale, the old CEO of not Mozilla, I forget, of Netscape. Everything is either bundling or unbundling. And AOL had bundled together the entire internet experience, chat rooms, websites, all that stuff. And then there was this moment where open standards came in and unbundled it. And not necessarily because of AI, but this moment where AI is putting into fluid, the kind of motion, this API environment. You have this very structured, closed down, locked down, and now you have this freedom that's going to be, the agents are going to go suck in all this data. It's going to go everywhere. What do you think that means for open standards, for security? Or could we have crypto decentralized Salesforce or something like that? Like, is that a possibility coming forward? Is that you start to get, in the same way you had websites emerge out of AOL, but these open decentralized way versus, and Facebook has obviously been trying to put the genie back in the bottle for the last 15 years. What do you think on that?
I don't think I have a strong opinion on it yet. Other than I suppose, is your question an extension of what we just talked about, where you have these siloed database businesses which have laid out APIs to allow all the data to flow out, and that's kind of a world where we could unbundle things again? Is that kind of
Yeah,
where you're
like
going with that?
there was no successor to AOL. I think Facebook is trying to become the successor to AOL, and I don't think they've ever succeeded, nor are they going to at this point. But
Yeah,
AOL wasn't replaced by AOL 2. It was replaced by an open standards.
yeah.
And I'm talking about AOL from like the late 90s when they used to send you the CDs every single day.
So there's a couple of things that I think are going to happen. What it leads to, I don't know. It's not necessarily in the open standards realm, but what is changing, what's going to lead us to. So we laid out all these APIs, which is great. We have now gotten to a point with speech to text and text to speech that it works really, really well. We have spent the last 10 years like this, including our kids, right? So we know that that's not good for us, right? We know this idea of interfacing with the screen is not just not good for us. And so, but we've actually unknowingly laid the sort of foundation to approach interacting with data and knowledge in a new way that's old, which is basically talking to and interfacing with, interrogating like a human. So a manifestation of that recently was the humane pin, and what was the other one? It's called Rabbit. These
Yeah.
sort of lapel based AIs. They didn't work. They got beaten up because they didn't work. But really, what they were is, for me, the first manifestation of a world where we don't have to be like this or like this to get to our data. And it's the same thing as you just said about the structured UI in HubSpot or whatever. So, how quickly this comes, I don't know. But we are getting to a point where we're not going to have to be at a screen, at a desk, on a phone to do things that are really powerful of a digital nature.
We've been pushing this harder and harder with our users, which is the voice interaction. And I want to just two data points, just like a bit of a speculative product. But one, people are so much more verbose when you ask them to do voice input versus typing. I think there's this kind of editorial thing, which is good. You want some editing, but with AI, you don't need editing. You want them to say everything that's on their mind, and the editing will happen later. And that's very different than asking someone, hey, type up a report, because so much of your mental process is self-censorship. And when you feel comfortable with an AI, that's one thing, is that if you give someone, hey, call them on a voice over internet protocol, simulate a voice, ask them some questions and get feedback. They will put in way more information. The average, Jira board, just because we're picking on Atlassian, is barely interacted with. I've looked at the data on like my old company, like how much it was. The people put in a couple tickets, they read a couple updates, and that's it. It's precise. It's the source of truth, versus people just go on and on about their problems if you can talk to them. The second thing is, and this is a fun change, and my team brought it up. We went from, when you're building AI the first time, you want to test that people actually use it. So you kind of go in, and it's you behind the scenes acting like you're an AI. Some of it's AI, some of it you're filling in the gaps, the old Wizard of Oz. And then what's happened is we would send bots, asking people for updates or interaction or to do things, and they would ignore the bot. And some users love the bot. Some just they don't ignore. So now we've had the bot simulating humans. Which, like, in a controlled way, they all know what's going on. No one's surprised by this. But when we ask a human being to prompt somebody and then again record the response, you get much higher rates. And so I think there's like this weird intermix of tapping into people's trust in a verbal format, and second, reproducing the social structure of, hey, there's a human being who's waiting for you. Because there really was human beings that were kind of getting prompted, like, hey, this person's not responding. So finally, when we had the human being as the front, it got a very different response. So I think those are interesting things and are probably going to shape a lot of what actually ends up working in the next couple of years.
Yeah, 100%. 100%. It's super, super exciting. I think that part of interacting with digital products, digital solutions is going to be phenomenal, right? We've just been in an age, we still are in this age of where it's detrimental, sort of socially, emotionally, mentally at points. And I think getting to a world where, um, my phone's right in front of me. It's always right in front of me. But this idea of I need to do something that has utility to check my email, but I get sucked into doing these other things.
Oh, it's
A
terrible.
world where I get prompted by Pact to answer a question that's relevant right now, and I can do that, and I don't get sucked into looking at Instagram for 35 minutes, right, or whatever it may be.
It's hellish. You're addicted to your phone, but every time you open your phone, like like you have like those digital cleanse weeks where you're like, I'm gonna leave my phone in another room. I'm not gonna check anything but this one thing I need to get done. I don't want to see any other email. But inevitably, you know what they do to you? They prompt you for the multi-factor authentication, and you have to go get your phone to log into your service. And it's
Yeah,
like,
yeah,
no, every time I'm out, they
yeah,
suck me back in.
yeah,
So,
yeah.
uh, so the question I had for you this week was, what are you seeing on your team internally using uh, these different modalities? And I'll say AI, but voice is kind of AI enabled to the point where we're not going to think about it as AI anymore. We're just going to think you talk and it gets transcribed. What are all of? I mean, I think one of the nice things about doing young startups is I'm not working with 3 layers of bureaucracy to make changes to our, how we
Yeah.
interact with our or how we build software or anything. You're in the same situation, so you're probably adopting some of these things much faster, but in a corporate environment, like you're running a company, but
Yeah.
you're adopting super fast. How's your team adjusting?
Yeah, it's really, really interesting because we've all been, you and I, man, have been in SaaS software for quite a while, and everyone in there's nothing particularly new in SaaS, so everybody's trained in it. We all understand in a sales environment if customer says, "Oh, can I change this?" The color of a button versus that, which is a new module. We all instinctively understand the amount of effort involved in that. So, a salesperson will sit there and go, "Ooh, that's a big one. Let me check." Let me go see if that's on the roadmap. In an AI driven product world, we don't instinctively know that. So it's fascinating. I'm getting all these questions from, the sales folks asking me like, is that hard to change? We were asked, could we do this thing? Can we do that thing? And so we're all learning how to kind of do new things. We're learning where the tripwires are. Um, Not only is the customer kind of having to work through that, but our internal folks are learning. And on the one hand, AI is amazing; it can do everything. But then when the rubber actually meets the road, it can't, right? Because it's really an interface between the probabilistic and the deterministic, and we don't know where all of that is. So it's just fun. It's learning, but I'm just really struck by the questions I get asked are so rudimentary, like, oh, can we even do that? Does it do that thing? I don't know. Whereas we knew all of that in the past. So I don't know. Your customers are slightly bigger than ours, and you're a little bit further down the road. What's it like for you guys?
Um, One of the things that we're doing with customers is providing, like an automated project manager, right? And so, everyone's been talking about Jevons law, whereas as the price of something goes to zero, ironically, the demand for it gets much greater. I don't even know why it's a Jevons paradox, but it just makes sense. You have your supply demand
Yeah,
curve.
it's a blind demand, yeah.
And for us, it's like, the people are starting, and I think this is probably where we're going to be able to differentiate as a small company, use it for things that they would have never hired a human to do. I think, the fear is that we're going to replace human project managers. Like, they got plenty of work. They have like 10 times more work than they could ever do. They're going to be fine for quite a while. And there's situations, for instance, like when you're working with a AI agent, you're developing code or something like that, and they say, "Well, I want Pact to help me project manage the AI," because you have to kind of like maintain a whole set of like, "Hey, here's what the AI is supposed to be doing. Here's what it's not supposed to be doing." And as I interact with it, I want the AI to remember. But sometimes, I switch between cursor and this other one because this one works one for one place, or I run out of context. So Google's doing Project Titan to help maintain that context, but there's these just kind of sci-fi scenarios of like you would never use a human to do that, but it's like, and you couldn't use a human to do it, but you can use agents to operate at these extremely fast time frames or in these extremely microscopic environments. Um, I think it just mimics, as things get smaller and smaller, you can put like with drones, you could put a whole cell phone with GPS into something light enough to fly, and you get this whole other realm of capability. I think we're going to be starting to see a lot more of that. Is just starting to say like, well, I know it's super overpowered to have a human level of intelligence do this, but API costs are cheap. Let's go do it. And that's something that I'm very sensitive to because that's exactly the kind of thing I want as a product leader. No, no, no. We're going to do something nobody else can do and become the leader in that versus trying to compete head to head with something that's already pretty well done, even though it can be done 5 times cheaper.
Yeah, we're really focused on trying to do really, really hard things, and a lot of things just got really easy. So, do you think of it that way? Is that kind of why you're focused on that?
You know, Satya Nadella said like AI. He's pulling back on data centers, and I watched his interview with Dwarkish this week, and he said, AI hasn't really met its promise. It's not how many questions it can answer, how much math it can do. It's do we get 10x or 10% global GDP growth, whatever, right? Gross world product, whatever it would be. Like when we're really solving big problems. And I think part of my concern about AI when I'm trying to fall asleep is like, is this AI going to completely obviate not just my business or our technology that we built, but me as a human? Like, is it going to just eradicate the need for human beings? And until we've run out of cool stuff to do, I'm not worried about that. We'll just go really, really fast. It's like there's all kinds of things. I mean, just talk about like Salesforce and Jira are still out there printing cash on stuff that they've had for 20 years. Like until that's gone, let's just go faster. Until we've built the cities we want and we're as healthy as we want and we're living the lives we want and the space stations are, look like 2001. Let's just go faster. I don't know. That's how I feel. I don't know if that was your question, but I had to get that off my chest.
There you go. There you go. Okay, last question for you. What did you see this week that was of interest?
This week I came in. I'm locked in. Quantum computers. So
This
my
is right up
background,
your. I want to hear this answer
my
because I
PhD
was,
is
yeah.
in quantum simulation. Not quite deterministic quantum. Like the kind of very close. There was a few different big competing things when I graduated back in 2011. Um, Ion quantum computing, cold atom quantum computing. Then you had these squids, and then there's the last one, which is topological quantum computers. And Microsoft announced this week. And if those 4 categories don't mean anything to you, don't worry. Just wait 10 years and see which one actually wins. But Microsoft announced topological quantum computers, which is a very exciting style of quantum computing because it's potentially very resilient to noise. And I think it could have a gigantic impact on computing. There's the basic ones are like it could do factorization of large numbers, which would break all security. So that's the one everyone's kind of engineering around. Are you quantum computing safe? And Microsoft is building an architecture that relies on very thin layers of material, which have something called Majorana fermions that emerge on them. And it's unclear how far along they are, if they detected the fermions directly, but I went and researched a little bit more this morning. It looks like they have built these 2D structures and they operate as quantum gates. And that just means that when you do operations on them, all of the quantum states like that are possible all operate simultaneously. And then you're only able to measure one, but in the background of this non-real quantum craziness, all possible states are getting calculated simultaneously, and then you can do interesting stuff, right? Anyway, the reason that the topological conductors or superconductors or topological states are really interesting is that they're, the analogy is these qubits, like in the squids and ions, they're so sensitive, and it's like a Jenga tower. If one little piece it hits a little piece of light or it touches something or there's a magnetic field stray, the whole Jenga tower collapses, right? And topological ones, topology is like the study of knots and holes and things like that. And so they're basically like knots. And what happens is the edge states of these topological quantum computers are are very stable. And so there's a possibility that if they could build these, no one's ever built it before, these Majorana 2D systems. And so if these knots can be built, you could potentially, and this is what Satya Nadella was saying, was you could build 1 million of these things. So I think the big things to watch are they able to turn these small superconductor, or sorry, these small topological quantum computers into multiple qubits that can interact? And then the big thing is, do they get to 8 or 9 qubits with long enough gate times that they can build error correction? And that's the big thing. And that's what Satya Nadella is saying. We're going to do error correction. We're going to do error correction. So that's the big thing to watch out is, can they take this brand new material, build enough of these qubits by each other that you get to 8 or 9, which then allows you to do quantum error correction. And if you can do that, then you could build these really scalable architectures on the same thing. So
where would, can you give us 2 or 3 examples of essentially what you're saying is from the physical, so the physical layer, you've explained to us, we can build it all the way up, but what are kind of real use cases that we would apply something like this to, which is essentially enormous amount of compute power available to us?
it's not an enormous amount of compute. It's a completely different modality of computation. And so things that when you do like a Turing machine, which is essentially isomorphic to all of our computers, like there's certain things that Turing machines do perfectly well, and the quantum computer is not going to really help you with it all. And that's everything we do with computers now. Quantum computers can do at least a few things that are absolutely impossible. Like to the point where it would take like the age of the universe for a giant supercomputer to ever even get one answer. And these things can be done in a few milliseconds with a quantum computer. So it's like, it's such a starkly different thing. And I think, there's Grover's algorithms and various ones like, prime number computation and like defactorization and stuff. I think once they're built, there's going to be a lot. And you just think, can you do whole bunches of things simultaneously? That sounds a lot like these AI architectures. I don't know what quantum AI would do. It's just a really hard problem. I don't know how AI works, and I'm not the best at quantum, like these quantum gate algorithms. But I bet if you had both at a company like Microsoft, they would figure out some really interesting stuff pretty quick. So it could be just as disruptive or far more disruptive than AI, because once you have these things, I think they'll figure things out really fast. It's just, right now it's physicists speculating about possible things, and doing it on paper, because there's no quantum computers in the world right now.
So this is an engineer talking to a physicist, which is fantastic. The engineer wants to know, so what are we going to use it for, Matt? What's the first thing that we're going to use it for? You kind of dodge the question a little bit.
Once you see, if you know this, you'll know if somebody has a real quantum computer that really has like large factorization capabilities, because they'll just start draining crypto wallets.
Okay.
That's what I love about crypto, is it's such a good indicator. Like if you see just large scale crypto just getting savaged, somebody has a quantum computer. And until then, you don't know. But it will really cause, because people do something called elliptic curve cryptography. And there's these mathematical things that to calculate these special keys that you send back and forth to encrypt. And once you have quantum computers, a lot of those techniques get broken immediately. And so not only will our existing communications going forward be available to anyone who has able to intercept the over-the-air transmissions, but all past ones as well. And that's a really big problem for government. So if you have a file out there that's encrypted now and a quantum computer comes along, well, they'll be able to go back and take something from 10 years ago and tell you where all your spies were, or drain your crypto wallet. And it's going to be a big issue. So anyway, but until you start seeing people complain about all their money getting stolen by a rogue AI crypto bot, don't worry too much about quantum computing.
Last question: how far off are we from real world application? Understanding that we don't really know where they're at exactly.
Look, you're not going to do anything interesting until you have error correction, and you're not going to do anything really interesting until you have thousands of error corrected qubits. That's when it starts to get. Because otherwise you could just take a big supercomputer, and everybody has like these big supercomputers now, and you could throw it at it. So it's like, a quantum computer might be interesting with 100 qubits, but it could be replicated pretty much by a big supercomputer with a couple months. When you start to get to thousands of error corrected qubits, which means that you can do lots and lots of gate operations before they decohere, that's when it gets really interesting. So this Microsoft, I think they had 1 qubit. I think is what they demonstrated. So you need eight or
Okay.
nine to get to a gate, and then thousands of, and then there's also gonna be all the architectures for keeping all of these things entangled. There'll be other error correction paradigms. You get a good 10, 15 years before anything crazy happens. But again, you'll know when when things start going very weird. I was just watching the newest Dead Reckoning was the Mission Impossible movie. I watched it. I watched the end of it last night. I've been watching over the last couple weeks, and it's actually really good. Like it's go watch the Tom Cruise movie. Enjoy it, but it's pretty accurate. I was like, oh damn, this is kind of what would happen. It's like suddenly things would start going weird in very odd ways, and that's I think how you'll know. But it's I
Okay.
think 15 years. It's always 10 to 15 years. Which, by the way, 1 year means you're going to do it. 5 years means it's possible. If this is physics. Physics, when you're writing a physics grant, this is how to break the code. You say it'll be done in the next year. It means the physicist actually thinks they can do it. If they say we're going to do it in 5 years, they think it's physically possible. If they say it's going to take us 10 years, they're pretty sure it's physically impossible, right? Like those are the different gradations. So if I say 10
Okay.
years for something to happen, if I'm in my physics mindset, I don't know, maybe it would never happen. I don't know. It's really hard. No one understands decoherence. It could be caused by gravity. It could be caused by, I don't know. So maybe correct me, but like it's an unknown thing. No one understands why it happens. Quantum computers are very spooky,
All
and
right. Well, so we have a bit of time, is what you're telling us.
yeah, probably 10, 15 years, yeah, or maybe no.
Okay. I'm going to throw in my quick observation for the week. It's at the other end of the spectrum in terms of it's in the I don't know the macro world. Um, we're talking about AI and really being in the digital world. I'm fascinated by at what point this AI world has interaction meaningfully in the physical world. So we talked in the past about world models, this idea of how do you kind of measure the world and understand what's going on in that world, and um, beginning to see more frameworks come out which basically bring IoT data and make it available to agents in real time. It's fascinating to me. All the work I think we're doing right now is really around digital labor and digital tasks. What happens when we can talk about physical tasks? So that's AI meets robots, maybe some that sort of that type of mix. But I think actually now that I think about it, probably 2026 is going to be a lot about that. It's about that digital and physical AI together.
I mean, I thought it was so stupid, and I'm just revealing my own ignorance when Elon Musk brought out that robot. It was an actually human being in a robot suit, and I think he's good at this. It's just getting pilloried, and like, oh, that's fake. And now you see 2, 3 years later, the robots are doing it. Like they're folding shirts and all that thing. I don't know how useful it's going to be, but certainly like you said, we've crossed the line from something being extremely hard to apparently not being that hard anymore. And that's just going to mean drastic changes very soon.
Yeah, I think the physical stuff is really, really, really challenging. When you think how flexible we are, if you were to design a human and you had the list of requirements, the things they needed to be able to do, and then, oh, by the way, they can learn to do new things as well. It's impossible. And I'll give you a very simple example. I was cleaning out my garage at the weekend. I pulled out the trash can. I was like, oh, there's a bunch of paper in it, a bunch of crap. Paper into the recycle bin, non-paper stuff into the regular trash. I don't know why I was struck by it at the point. Some sort of robot plus AI the task of working that out.
That was my whole childhood is crushing aluminum cans.
Yeah,
And
virtually
look,
impossible to do.
I think all of this stuff is super interesting, but we're still using Jira. We're still using HubSpot. HubSpot's a great tool. I love it. Salesforce. I'm saying like the transformation hasn't even come to digital yet, and we're still driving our own cars. And Waymos exist, but it's for some reason I can go a few miles down to Austin downtown and I can take a Waymo, but it won't come to my house yet. So it's like I think that should be a signal to everyone that there's something beyond just technical capability that's stopping us. And Tyler Cohen had a great article this week on why he thinks it's going to go a lot slower. And I think that's where all the opportunity for entrepreneurs is because
Yeah.
it's not just technology, it's getting it to actually be real, like you said. Anyway,
Yeah. Great. All right. Well, let's land the plane, Matt. Good chatting to
excellent.
you, and we'll be back next week.
See you next week.
All right. Bye.